This question, number one, it deals with discrete probability distribution. It says a random variable x can take the values 2, 4, and 6. The probability distribution of x is given in the following table. So here we have a random variable, and the values that it can assume is 2, 4, and 6, and the probability that x will be equal to 2 is 0.14. The probability that x is equal to 4 is 0.46, and the probability that x is equal to 6 is 0.4. So it says it is asking to calculate part A, the probability that x is equal to 4. So I've just mentioned it. The probability that x is equal to 4 is 0.46. Now, part B is asking the probability that x is at least 4. At least 4 implies greater than or equal to 4. So that would be 4 or 6. Now, when you are doing probability analysis, if you mention the word or, that implies that you've got to add. If you mention the word and, it means that you've got to times. However, and in arithmetic is plus, but in probability analysis, and is times, and or is plus. So at least 4 means 4 or 6. Okay, so therefore now we have to add the probability that x is equal to 4 plus the probability that x is equal to 6. And that will give us the probability that x is at least 4. So here we have it, the probability that x is at least 4, meaning the probability that x is greater than or equal to 4 is 0.46 plus 0.4, which is 0.86. Now, part C now says, what is the expected value of x? So this means we've got to calculate the population mean. So we've got to call up the formula for population mean from a distribution, probability distribution, or probability model. Now for this, we got to go to unit 3. So here's the formula to calculate the mean of the population mu of a probability distribution. Is the sum of x times p of x, meaning the sum of the product of each value of the random variable times its associated probability value. And here we have it in a different version. E of x is equal to the total of x times p. So we've got to multiply each value by its corresponding probability, then add them up, add up the products. Here we've got an example. All right, and it says that we have to find the mean of this probability distribution. As you can see, we found the product of x times p of x, and then these products will total to get a value of 2.94. So that's what we are going to do in our example. So here we're going to use Excel to help us do that, because we're going to find sum product. We've got to multiply and add, so we can easily use Microsoft Sheets or Excel to do that. So in this column, we are going to lay out the variables of the 2, 4, and 6, and increase the font. So let's list the probability values: 0.14, 0.46, and 0.40. So now we need another column called XP, or X times P of X. X times P of X. So we're going to multiply each value by its corresponding probability. So we can easily create an equation to do that. So that will be equal to A1 or A2 times B2. Oh, it actually anticipated that's what I'm going to do. So here it is. So we just click enter. So that's 2 times 0.14, etc. So what we can do is to drag this formula to all these corresponding cells. And here we have it. And here now we're just going to find the total by using the sum function, or we can just type equal sum, find the sum from C2 to C4. And that will give us the expected value. So we can type here the expected value of x is equal to 4.52. Now, part D now is asking for the variance of x. Now we can see here there are two methods to calculate the variance of x. We've got method 1 and we've got method 2. Now, method 1 says to find the variance of x, we've got to find the deviations, square the deviations, and multiply by the probability of x. X minus the mean all squared times p of x. And when this is done for each p of x and its corresponding probability, then we add this up. Version 2 says that we go to square each variable multiplied by its corresponding probability, then add up, then minus the mean square. So we can take either method. Let's do method 1. We are going to apply method 1. But you are free to choose method 2. As you can see, both methods would demonstrate here. Both methods would demonstrate it here. Method 1 and method 2 for this example, example 3.2. So as you can see, for method 1, you've got a final column called P of x times x minus the mean all squared. Okay, so we can just create a column with this heading and just do this right away because we are going to use Excel, okay, to help us, or Google Sheets. So applying method 1, we've got to create a column called P of x times x minus mu. I'll just use the word mu all squared. Okay. Let's find this a little bit. Right. So basically, we can do this with one go equal P of x times open bracket x subtract the mu, which is 4.52, close bracket all squared. Okay. Again, P of x times open bracket x, which is in A2, that's the first x, subtract the mean, 4.52, close bracket all squared. And here Google wants us to autofill, yes. Control enter to autofill. Control enter to autofill, yes. And autofill meaning to drag the formula to copy the formula to all the corresponding cells lower down. And here now we're going to add it up, so we can just drag the sum formula here, and that will give us the total of the variance 1.88896, and that would be D, and that would be the variance of x is equal to 1.894. three significant figures. And here we have it for this question for number 1, assignment 3.